Let's take a look at some examples of graphing quadratic equations the easy way. In the following examples, we're going to graph the following equation, list the transformations, and identify the domain range. I know by inspecting my equation that I have x plus 2 squared, and this value inside our parentheses here is going to be our horizontal shift left or right. Because it's x plus 2, it's going to be a horizontal shift to the left 2. And then we subtract 1, and that means it's going to be a vertical shift down 1. So the vertex for this particular equation is going to be -2, -1. And again, please note that the sign is always going to be the opposite of what's inside the parentheses here. So x plus 2 is going to shift it to the left 2. And so I start at the origin, horizontal shift left 2, vertical shift down 1. And there's my vertex for my parabola. Now let's direct our attention to the a value. Well, the a value in this particular equation is a 1, because 1 times quantity x plus 2 squared is going to be x plus 2 squared. Since our a value is 1, there will not be a vertical stretch or compression. So we will have our standard parabola at this vertex. So starting at this vertex, if we go right 1, 1 squared is 1, so we're going to go up 1. If we go right 2, 2 squared is 4, so we're going to go up 4. And the nice thing about quadratic equation is the line of symmetry, so I know that if I go left 1, I'll go up 1, and then if I go left 2, I'll go up 4. So now that I have my 5 points I need to graph quadratic equations, I can now draw my familiar U-shape. And that's the quick and easy way of graphing a parabola. I'm sorry, because of my technology, I'm unable to graph the parabola the way it should be. So the next slide will show the way it should look. Now the geometric transformations. I know that because of the x plus 2, I have a horizontal shift left 2. And the -1 tells me a vertical shift down 1. Now let's direct our attention to identifying the domain and range. The domain, again, is all x values for our function. So if you notice, the graph is going to the right and to the left and everywhere in between, so the domain is going to be all x values, or -infinity to +infinity. The range are all the y values, so the graph comes down, hits -1, and touches, and then goes back up. So we are going to include -1, and since it's going up, it's going to go to +infinity. And that concludes example 1. By inspection, I know because of the x minus 1 squared that my graph is going to be shifted horizontally to the right 1. And I also know, because I add 3 to that my graph's going to be shifted vertically up 3. So my vertex for this particular equation is going to be 1, 3. Right 1, up 3. And that's going to be the vertex for this particular graph. Now my a value for this particular equation is going to be -2. So that tells me that there's going to be a reflection as well as a vertical stretch of 2. So if I were to graph this parabola normally, I would go from the vertex to the right 1, 1 squared is 1. And I would also go right 2, 2 squared is 4, so I'd go up 4. So I would graph those points right there. However, that a value changes everything. I know that instead of going over 1 up 1, I know that I'm going to have to take this value of 1 and I'm going to have to multiply it by -2. So 1 times -2 is -2. So instead of going over 1 up 1, I'm going to go over 1 down 2. And that's what that A value does to my particular graph. Now the same thing can be said for the next point. For my vertex, I'd go over 2 up 4. Well, I'm going to take that 4 and multiply it again by -2. Now why am I multiplying by -2? Well, that's what I'm doing to my equation. I'm multiplying my squared term by -2. So that gives me -8. So instead of going from my vertex right 2 up 4, I'm going to go from my vertex right 2 down 8. And because of symmetry, I know I'm going to go left 1 down 2 and left 2 down 8. And so now I have my 5 points I need in order to graph this example. And again, I'm going to do my very best job to draw my U-shape. And again, I wasn't able to do parabola justice, so the next slide I'm going to have technology graph it for me. And that's what our parabola should look like. Okay, now a list of geometric transformations. Again, because the x minus 1 squared, there's going to be a horizontal shift right 1. And because of the plus 3, there's going to be a vertical shift up 3. And now the A value of -2 tells me that there's going to be a reflection, and a vertical stretch of 2. Now please recall that there is a difference between a vertical shift and a vertical stretch. A vertical shift shifts the whole graph up 3. And a vertical stretch stretches all the points by a multiple 2. So all the values got stretched vertically. Lastly, identify the domain and range. The domain, because the graph is still going left and right and everywhere in between, is still going to be all x values. So -infinity to +infinity. And again, the range are all the y values. Now if you notice, the graph is pointing down, so it's going to have all negative y values until it hits here at 3 and then goes back down to all negative values. So my range is going to come from -infinity and end at 3. And since it touches, it's going to include the 3. And that concludes this example. Now again, by inspection, I know that this particular graph is going to be shifted to the left 3 because I have an x plus 3 quantity squared. Now notice that I'm not adding or subtracting anything to this function, so I'm not going to have to shift my graph up or down. Therefore, my vertex is going to be -3, 0. So now that I have my vertex, I can start at the origin and go left 3, up or down, none. So that's where my vertex is going to lie. Now if I didn't have this A value of 1/2, I would go right 1, 1 squared, which is 1. I would go right 2, 2 squared is 4. And in symmetry, I would graph those 4 points there, and that would be my parabola. But I do have an A value of 1/2. Well, that A value of 1/2 tells me that there's going to be a vertical compression, which means if I multiply those values by 1/2, they're going to be half as big. So I'm going to compress those points vertically. So where I would normally go right one, up one, well, half of one is a half. So that's what compression does to my graph. In the case where I would go right 2, 2 squared is 4, half of 4 is 2. So that value right there compresses all my values vertically. And again, because of symmetry, I now can plot my other 2 points. Now that I have my 5 points, I can now draw the graph of my quadratic equation. And again, to do my very best to draw my U-shape, and there's the graph of this particular function. Again, using technology, this is what our graph should look like. And again, because I have x plus 3 squared, that means my graph got shifted to the left 3. So I'm going to have a horizontal shift left 3. And there's no k value, so there will be no vertical shift. However, I'm multiplying by 1/2, so that means I'm going to have a vertical compression of 1/2. Now to identify the domain and range. Well, again, my domain is going to be all x values. So from negative infinity to positive infinity. And now my y values, well, if you notice my graph is going up, and the lowest value here is a 0, and it comes down and touches. So I'm going to include 0 and go to positive infinity. And that concludes how you can graph quadratic equations quickly.